Sweet giant aunties of Santa Anita. That's a lot of calculators. That's probably what you're thinking, and that's for the Futurama fans. But yeah, probably something along the lines of that's a lot of calculators is going through your head. Well, for me, not so much. I'm a number file. I love mathematics. Hated it when I don't know why. I wouldn't say I hated it, but I didn't like math that much when I was a kid. I did it, but yeah, as I got older, got to loving math, and well, of course, what goes with math? Calculators. So, yeah, and they're electronic, so yeah, I gotta collect them. I've got, just the other day, now have, what, 820 different makes and models of calculators, not all scientific. And that doesn't count my adding machines or old mechanical, what you would call old mechanical calculators. Because I collect all of that, and probably grand total I probably got over 2,000 calculators, honestly, because a lot of times I'll buy lots or bundles of old vintage calculators, and there could be 5, 10, 15, 20 or more calculators in a lot, and some of the really popular ones over the decades, like the old Texas Instruments TI-30, one of the original scientific calculators. I've got probably close to 24 of those things. But this video is specifically, I've been asked a couple times by people, what's a good scientific calculator for use in basic electronics? That is a deep, dark hole. It's, can be a biased question, I guess you could say. It's kind of like a car. What's the best car? Or truck, or whatever. But yeah, it's, it's a loaded question. The calculator I might tell you is the best, you might not like. It's the best calculator is honestly the one you like the best. So I'm going to recommend 4 different calculators. They're all the same brand, and the reason is if you buy a cheaper calculator, one with less functions, and in the future you want to upgrade to a better one, if you stick with a brand, whatever it might be, HP, Texas Instruments, Casio, but if you stick with a brand, as you, over the years, upgrade to better and better calculators till you finally get up to some of the premium ones that are basically just computers that do math really well, but your transition will be easier because the functionality, just the way they do things, button layout will be very similar. So if you stick with Casio or you buy a Casio, stick with it. If you end up not liking them, or you might like Texas Instruments better, or you might like HP better. But if you stick with a brand, you're going to find that transition's easier if you upgrade in the future. Or just if you're like me, you have lots of calculators, and like on this bench here, I actually have 4 within arm's reach at any given time. But if you stick with one brand, you'll get very familiar with how that company, their layout, and just how menus might work when you get into the more advanced models. This video is not, it'll have meaning for people that are going to school, but this video really isn't for people that are going to be in middle school, high school, taking technical courses in school, or college. If you're in school, your instructors or the school is going to tell you, you have a choice of either that calculator, that one, or that's the one you have to have. You may only have one choice. Or that it has to meet a certain specification, because a lot of these calculators, the more modern ones, not the antiques, but the more modern ones, they're approved for SAT testing or whatnot. So this video is not for people like that. Like I say, there'll be some meaningful stuff in here, but what calculator you should have is really going to be dictated by your school, what they tell you have to have. This, and most of my picks, and I'm going to get some flames when I show the brand, people that are, because it's just like with cars, who makes the best car? Well, it's the same thing with calculators. Some people are going to tell you, oh, this is better than that. It's just a very personal thing. I picked the calculators that I picked. Most of them are in the lower price range, so their affordability. Availability was another important thing. I think 3 of these are available at CommiMart or Walmart. So yeah, you can walk into the local CommiMart and get 3 of these things. Functionality, and as price increases, you get more functions in a calculator. Durability, honestly, most calculators, quite honestly, HP, Texas Instruments, Casio, yeah, they're pretty much, yeah, they're all good quality. The more you pay, the better you get. Sharp, I don't know what happened to Sharp. We'll get into the green piece of junk there. But, yeah, pretty much the four that I picked, it gives you a range from the cheapest up to the best in normal scientific, and then I threw in, I was going to do two, and then I decided on three different ones, and I added a fourth one. The fourth one's programmable, but it is not a graphing calculator. So if you just want to know what are my suggestions and not have to watch the rest of it, I'll show those. There is going to most likely be a second part to this video, so it'll be a two-part thing. This is going to be just an overview of calculators in general. The second part is going to be a little bit more hands-on here. I'll demonstrate actually using them, what they look like, how a calculator can make your life easier, what some of the calculators I'm not recommending, the advantages of those. So I'll probably use like the HP Prime, in my opinion, probably the best calculator made right now. Big learning curve though, and that's another thing we'll get into. But the four that I'm going to pick are Casios. So flame away HP and Texas Instrument fans, and Sharp fans, or whoever your favorite brand might be. Like I say, these just kind of fit the bill. Easy to find, decent quality, very good function set. Honestly, I think with especially this one here, they've just got so many things right that it's, man, there's just, I don't know if there is anything else, and I pretty much own every calculator that's made nowadays, you know, all the modern ones. In this price range, I think this is the best calculator there is. For the amount of money, there's just nothing else that compares to this one right now. Currently. Tomorrow might be a different thing. But the four that I picked, starting with a basic one-line, basic scientific calculator that's pocket size. So you stick it in your shirt pocket and in a couple minutes you'll forget it's even there. This is the FX260 Solar 2. So this is the Roman numeral 2. This calculator has been around for so long, they reintroduced it in a second version. This thing's been around for a long, the original 260 Solar has been around for a long time. I've got a couple of them, and they're great little calculators. I keep this one on my bench. Actually, this one and two others are within arm's reach at any given time at this bench. I like both of these, really. They're really nice. Like I say, this is a good basic little calculator, one line. Both of these have, and in the second part you'll see when I get into the functionality of using these, you'll see the displays, but these have what is called a natural or textbook display. I specifically picked this style, and this is where teachers are going to hate me, but if you're not going to school, you don't have someone looking over your shoulder, you know, to teach you mathematics, because honestly, most people, if you're just getting into electronics, you know, and you've been out of school for several decades, you've probably forgotten 90% or more of everything you ever learned about math. You can add, subtract, multiply, and divide, do a little bit with fractions. You might do a little bit of geometry and algebra, not realizing that's what you're doing, but you know, do a little bit of algebra and maybe some geometry, you know, especially if you do woodworking or something like that. But yeah, honestly, anything more complicated than that, you've completely forgotten about it. These calculators will make your life really simple. You don't need to know math, really, to use these, to do very advanced mathematics. These, with their natural textbook display, and Casio's not the only one that does this. Everybody has a version of the textbook displays. But it's very easy to do math on these because you can just pick the formula. It's on the screen with blanks, and you just fill in the holes. You don't even need to know how the math works, and you can get the answer. And quite honestly, I've got to remember, I'm a number file. I love mathematics, so it pains me to say this, but what is the most important thing with doing math? Getting the right answer. Honestly, how you get to that right answer doesn't really matter, does it? If you think about it, what matters is the answer and that it's correct. You don't even honestly need a calculator nowadays. You can do it with a program or an emulator online. I like calculators. There's nothing beats having a dedicated calculator. But like I say, these are both really good. This is the FX115ES Plus. This is the FX991EX. This one has a lot more features than this one, but as far as electronics is concerned, the features that this has, yeah, there's some you might use, but honestly, for electronics, they're both fully capable. This one, if for no other reason, I'd pick this one. It has such a nice display. Let me just look here on the bench. Yeah, there's only 2 calculators actually I have laying on this bench right now that have a better display than that one, and those are going to be the higher end color displays. Those are basically like your cell phone or tablet, and this one's even a touch screen. You know, really fancy high-end color displays. As far as just a single color LCD display goes, this is about the best display I've seen on a calculator. Has just the Casio, just their functions. Where if I go over to a Texas Instruments, anytime I want to do anything even halfway advanced, a lot of times I got to go into a menu to do it. This, don't get me wrong, has menus and lots of features that are buried in a menu, but Casio has gotten really good, and they've actually been like that for a long time. You know, here's an older one. I used this thing for a long time. That's just one thing they've always been good at, is having a lot of functions that aren't buried in a menu. You just hit the shift or the alpha button to get to these additional, you know, or secondary functions on a calculator, which is kind of nice. This one is just well thought out. Good interface, good display. Now this one is a solar only. Both of these are solar and battery powered, which this is the only solar only calculator on the bench. Anything else you see here that has a solar panel, they're dual powered. Be it Texas Instruments, Casio, doesn't matter who. But they have a solar cell as their primary power source, and if light conditions are low, they also have a coin cell battery in them. Basically, it's kind of like a backup reserve. But really good calculator. And about as advanced as you can get in a scientific only calculator. The only thing you could do really to make this one more advanced is this one. Now this one does not have as nice a display as this one, but this is a programmable calculator. Now price wise, you're going to have to forgive me. I collect calculators, so I'm just, you know, when I see a new one, I buy it. I don't really pay that much attention to price. It's kind of irrelevant to me because I collect them. But I think this one's in like the $6 range. Forgive me if my prices are off, but I think I'm going to be fairly close, and it honestly varies where you get it. Walmart, Amazon, eBay, the local grocery, or, you know, stationery store can really vary. But I think this one's around $6. This one's around $12. I think this one's around $16. This one costs more than all 3 of these combined plus some. But this one adds programming. I wasn't originally going to include one, but for those of you, if you do already own scientific calculators and you'd like to get a little bit more advanced, that's where you start getting into a programmable calculator. So I figure I'd just toss one into the mix. Again, it's a Casio, so you know, if you were, like I said, stepping up, this is the perfect example. You step up from the basic to a really nice scientific calculator to one that's even more advanced to one that's programmable. Your transition going up is going to be a lot easier if you stick with the same brand. Same thing with Texas Instruments. You could get a basic Texas Instruments calculator, you know, something like this, and progress your way up to something that's more advanced. Same thing, brand doesn't matter. Just like I say, pick a brand and try to stick with it if you ever plan on upgrading in the future. But like I say, this one adds programming. I think it has like 128 formulas already programmed into it, and then you can program. You can add your own programs and save them. Also, this thing has a just ridiculous amount of variables you can save in this thing. It's in the thousands. Now that depends on how much memory you've used adding programs into this. But yeah, you can do like over 2,000 variables you can save in this. It's just ridiculous. I don't know what the heck you would ever need that many variables for, but like I said, I just figure I'd give an option if you wanted a programmable calculator. But complexity comes with that too. As price increases, you get more functions, but along with those functions comes complexity, which just makes them more complicated to use. The owner's manual for that, yeah, it's a sheet of paper folded up a couple times, little tiny book. These, yeah, add a few more sheets of paper, but it's still folded up into a tiny little pamphlet. There's not much to it. Still basically a normal scientific calculator with a few menus. This one, you get a book. It's not very big. It's only about that thick and, you know, like that big, and a little bit wider than the calculator is. But yeah, it's fairly small. I am specific. Oh, I forgot the model number to mention that. This is the FX5800P. Like I say, that one's for if somebody wants to get into programmable calculators. And that's another thing, depending on what brand you buy, the programming language is going to be different. So, you know, this one uses Casio Basic is the programming language. Actually, it's Casio Basic 2, which has been in use since I think 1995. I think they've been using Casio Basic 2. Programmable calculators before that used Casio Basic 1. But I am specifically not recommending graphing calculators or the fancy ones. Reason is stepping up. No, this one's so simple a caveman can use it. Using these, like I say, it's still just a basic calculator, at least getting to the functions, getting into the few menus. Yeah, it's nice to have a little pamphlet, but yeah, anybody can pick up how to use these. This one's more complicated. It's the scientific calculator, but it's added pre-programmed in programs and the ability to add your own program. So that's why it has a book instead of just a little tiny pamphlet. It's actually, you know, a little bit thicker. But when you step up from something like this to this or this or this, you know, any of the graphing calculators here, you go from a little book to a phone book. And that phone book could be like the size of New York City. Graphing calculators can have owner's manuals that go from, like, you know, 300, 350 pages up to, like, for the HP Prime, and you don't even get a book when you buy these really fancy ones. They just give you a CD. But I think the manual for the Prime is like 750 pages. Yeah, that is a lot of book for just a calculator. They're very complex. Now, it's not that they're that much harder to use, but to get the full benefit of what you're paying for, all those additional features, yeah, you have to read all of those pages. And honestly, you don't need all those features. Now, there are advantages, and I'm going to demonstrate that with the HP Prime. In the next video, I'll show like series parallel combination circuits, like you've taken a test. You know, they'll have several branches of parallel circuits and series resistance, and you need to calculate the circuit equivalent resistance. Doing it on paper or doing it with a normal calculator, it's a lot of writing, probably like a half page worth of formula you'd have to write down if you did it longhand. It would be a lot of key pressing on a normal calculator. Doing it on that one with a very simple 4-line program, you can simplify all that math down to one little formula, one line. That's all you need to type in to get your answer. So, like I say, there are advantages, but those advantages come with complexity. Now, programmable calculators, you know, they've been around for decades. Here's some old vintage ones, an old Sharp and an old Tandy. Now, the Tandy is just a rebranded Casio, but, you know, so, you know, this kind of stuff, this technology, programmable calculators, has been around for a long time. I'm not recommending HP calculators either. I'm not recommending graphing calculators because of complexity and cost. They cost a lot more, but the main reason is complexity, and it's complexity that you just don't, most of it you're never going to use. I'm not recommending HP. The HP fans are going to flame me because I'm not recommending HP. And now, remember this, HP fans, that calculator and that calculator also live on this bench. So that one, remember I'm a collector, so I like variety is the spice of life. So, yeah, I've got 2 Casios and 2 HPs on this bench. And I probably use the HPs as much as I do the Casios, just because I like mixing it up. But I'm not recommending the HP calculators for the average person because, you know, this one's kind of a hybrid. The original HP 35 was an RPN calculator. This is a re-release, I guess you could call it. So this one does RPN and algebraic input. Now, for a lot of you, you're probably thinking RPN. What the hell's that? It stands for Reverse Polish Notation. If you don't know what it is, you probably don't want an HP calculator. If you already know how to do HP, or if you already know how to do RPN input, have at it. It's a fantastic system. And for decades, the advantage of RPN was you could punch in basically a very advanced formula into a calculator with less keystrokes on a calculator that used RPN, less keystrokes than you could in a normal scientific calculator. This isn't a good example because, like I say, this does both algebraic and RPN input, but the originals. There's no equals sign anywhere on this calculator. There are also no parentheses or brackets. They're not used in RPN input. So, normal calculator. You pick up this little critter here, you want to do a simple addition. 1 plus 2. That's exactly how you type it in. The number 1, the plus sign, the 2, and then you hit equals. And it gives you the answer of 3. That's not how an RPN calculator works. RPN calculator, let me make sure my stack's cleared out here. Okay, RPN calculator, if you wanted to enter that, or if you typed it in just like I did on that one, for starters, there's no equals sign. Now, there's a lot of these calculators, like the Texas Instruments, they're pretty good for sticking enter. So, you might see enter on here and figure, okay, that must mean equals. Well, if you push in 1 plus 2, enter, what do you get? 2. Well, 1 plus 2 does not equal 2. 1 plus 2 equals 3. Obviously, there's something amiss here. So, the way you would actually input that in an RPN calculator is 1, enter, 2, plus. Notice I never hit an equal sign. And like I say, if you look on this calculator, there's also no parentheses or brackets. It's because they're not needed with the way you do RPN input. It can be very confusing. Honestly, RPN, it's either you love it or hate it. If you learn to use it, you probably love it. It's great. Now, honestly, nowadays, with calculators like this, with these natural displays, I've actually done keystroke counting. I'll do something on this calculator or any of my other HPs in RPN mode, or even other calculators. Doesn't need, because there are other companies have made RPN style calculators. Here's a National Semiconductors. This is an RPN input calculator. Notice no brackets, no equal sign, has an enter. It's exactly the same as an HP, the way this one works. But for decades, it was faster to input big formulas in using RPN than it was a normal scientific calculator. Because of those missing, you didn't need to type in parentheses or brackets. You didn't need to hit an equal sign. Honestly though, I've done some counting, and a lot of times I can do what used to be faster on one of these, or one of these. I can do it faster now on one of these natural displays, because I can bring up the formula on this like that, fill in the blanks, done. Where this one, and these are more complex to use. Using an RPN calculator, you need to really understand the mathematics. It needs to be done in a very specific order how you do stuff. You need to know order of operation. These calculators, again, not so much. As long as you know you need to, fill in the blanks. As long as you fill in the blanks correctly, they'll give you the right answer. They're just easier to use. These calculators force you to think about the math. You really need to know how it works, and you have to think about it. You need to break it down into little chunks to do it in RPN. These calculators, you don't. You just punch it in exactly as it looks on paper, and it gives you the answer. RPN's fun to use, though, like I say, for calculator junkies. So, now, there's lots of I got out a lot of calculators just to show you. There's been a lot of different types of calculators made over the years. Like I say, from simple, little small calculators, like here's an old Sharp. I've had this one. This is an original, I bought years ago, brand new. Have used it for decades. Works great. It still works. There's nothing wrong with it. Up to the most advanced calculators and everything in between. Like I say, programmable calculators. These are some of the early, a lot of times they'd call these pocket or scientific computers. Didn't even call them calculators. Like this one is the scientific computer EL5503. And I've got the accessories for this. You can get, and a lot of these calculators like this, or computers, had accessory modules and programming modules. There's a printer this thing snaps into, so you can print with it. Yeah, it's just all kinds of stuff you can do. You know, old calculators, honestly, you know, if you get a used calculator, now let's start off. If you buy a used calculator, be really careful. Even brand new calculators, quite honestly, you can get a piece of junk, or with a corroded battery compartment, brand new. That green piece of junk is a good example of that. That calculator, brand new out of the package, I opened the battery cover on it, and what did I see? The cheap, no-name coin cell that they had in that thing for the battery was leaking, and the battery terminals were corroded. Brand new calculator, not like it had been sitting on a shelf for years. It's brand spanking new. Bad battery, leaking, corroded battery terminals. So if you buy a used one, be it in person, at a flea market or somewhere, or at a public auction, or someplace like eBay or Amazon, if it's used, try to make sure you can see the battery compartment, make sure it's not corroded. Second thing is, make sure the seller guarantees the blasted thing works, especially if it's a Texas Instruments, just normal scientific, or any brand of graphing calculator. Usually the only people that have this type of stuff are students, you know, that are going to be selling them. They go to school, they use it, and then they get rid of it. They've been used by kids. They've been beat around in book bags. They've been beating each other over the heads with them. God knows what kind of biological warfare has gone on the keypads on these things either. So yeah, you want to clean it before you go using them. Because yeah, just imagine kids in college drunk. Yeah, Lord knows what's happened to the 4 keypads on these things. So, but make sure it actually turns on. It's so common to see, and it's not brand specific. It's just any of them. Trust me, there is no such thing as the kid-proof calculator. So, broken displays, calculators that are just bricked, they're locked up, displays that are all black, displays that are blank. You know, if you can at least see the display with a bunch of numbers on it, that's a good indication that it at least probably works. So, that's a good thing. And ask to see the battery compartment as long as you don't see any corrosion. Again, that's a good thing. But honestly, the price of these calculators nowadays, yeah, just buy a new one. Now, if you like vintage, that's fine. You know, there's nothing wrong with a vintage scientific calculator. A TI-30, very popular. They called these the Electron. That was, you know, Texas Instruments' nickname. If you look on the face of the, I don't know, do I have an owner's manual here? Yes, I do. There is an owner's manual in the pouch for this. And you can see what they called it. The electronic slide rule. So yeah, that kind of tells you how old it is. If you're a kid, you probably don't even know what the hell a slide rule is. But you know, that's what stuff like this replaced. It was slide rules. But even this, for a large majority of what you do, it'll get the job done. It's going to be a lot more complicated than doing it on a fancy natural display. But honestly, it gets the job done. You know, you can square, you can do powers. You know, it's got exponents. So, you know, very important in electronics, because you're going to be dealing with really big numbers and really teeny tiny numbers. Big numbers would be like a frequency. Could be in the megahertz or gigahertz. So that's a 1 with a lot of zeros behind it. Likewise, you could be dealing with really small numbers like capacitance in the microfarad or nanofarad or picofarad. So a decimal point with a lot of zeros after it. So pretty much any new calculator will do it, but even the old ones, they had exponents. You know, you turn this on, and this is an old bubble display, so, you know, the 7-segment displays are actually little teeny tiny things. They put these little domes over them. They kind of like act as a magnifying glass so the numbers look bigger, but, you know, this does exponents. You know, if you want to do, let's say, I don't know, 58 times 10 to the, let's say, 12th, bam, there it is. There's the number, and there's the power. You know, times 10 to the 12th. It does exponents. So, you know, you can do that, adding very big or very small numbers. So, you know, and it has your basic scientific functions. Very basic, because each button only does one thing, but it gets the job done. And it's retro. It's kind of cool. Same thing with, you know, this National Semiconductors. If you're into RPN, again, it's just an old retro cool calculator. Like I say, don't recommend the graphics ones, just very complicated, especially if you're learning. If you want to, at some point in the future, step up to getting a graphing calculator, that's fine. Learn how to use a normal scientific calculator first, though. Don't just go diving in head first. Going from a calculator that doesn't do anything but add, subtract, multiply, and divide, and jump into a graphing calculator or something like that, that's like running head first into a brick wall at full steam. Step up to get into a scientific calculator, get comfortable with using that, and then if you at some point in the future want to use a graphing calculator, I'd at least recommend going to a scientific calculator before stepping up to the graphing calculator, because the graphing calculator is just a scientific calculator, does all the same things usually, but just a lot more because it has a graph on it. Now, if there are some downfalls to calculators, and most manufacturers have some downfalls at one point or another, and they have good things too. Good things are probably the best built calculators ever are HP's. This calculator was made, for starters, in the USA. I don't know if you can even see that. 24, so what's that, 1984, and then 02, so it was the second week of November. So the second week of November in 1984 is when this calculator was made, and it still works. And you can see it's had the snot beat out of it, well used, dinged up, banged up, still works perfectly fine. One of the things about HP is that nobody else has ever recreated is the tactile feel of an HP button. If you're a calculator nut, it could only be described as orgasmic. It's just, the feel. Just the feel of an HP calculator button compared to any other calculator. There's just nothing that compares to it's the same, the tactile feel, the break point. It's just, they don't wobble. They're just very built like a tank. And just, they take a licking and keep on ticking. Comes at a cost, though. Even these two calculators, and I'm recommending these two, especially this one, like I say, does an amazing amount of stuff, great display, very cheap. Even these have something I don't like, though. These, Casio, they just need to stop this shit, because this is enough to drive me nuts. They're trying to get fancy looking, and they're not the only company. They're all trying to do it. You see that? It looks like carbon fiber. That's not carbon fiber. That's just molded into the plastic. But you hear that? It's three-dimensional. It's, like I said, molded into the plastic. Well, what did they do on top of that? They printed all the text. The secondary functions of all the buttons. It's printed on that. Now, that's fine when, the calculator's 3 inches away from the camera lens. But, in person, calculator's sitting down there on a bench, and I'm trying to use it. Depending what angle the light's coming in, because the text is printed onto a three-dimensional surface, the reflection, it's the yellow or gold is easy to read, but honestly, the alpha and the red and the blue stuff, man, it can be hard to read at certain light angles. Not to be outdone, Texas Instruments had to do some shiny shit too, so they've got the chrome button here. Now they have a nice flat surface, and Casio. Do I need to launch this calculator into outer space? Does it need to be aerodynamic? No, it doesn't. Just stick with the old rectangular box. Stick with what works. But everybody's got to try to outdo everybody with looks nowadays. A calculator should be rectangular, square, flat, and boxy. That's all I need. But like I say, Texas Instruments, they got to do something too. So they got the chrome cursor button, but then they also had to do division, multiplication, subtraction, addition, the swap key, and the enter key. Well, they did those in Chrome too. So if you're not 100% familiar with this calculator and have memorized what all those buttons do, depending again what angle you're at, you get that. You get blinded by the Chrome. You can't read the button because it's so reflective. Again, why? Do I need Chrome buttons? No, I don't. Not to be outdone, somebody had to outdo both Casio and Texas Instruments. And who was that? Well, that was Sharp. Which saddens me, because Sharp has made some really nice calculators over the years. This, I wouldn't recommend to my worst enemy. You see that? They made the entire face of the calculator a mirror. Yeah, you need a welding helmet to prevent the glare you get off of this thing. I mean, really? A glossy faceplate and glossy buttons. I mean, I don't, what do you say? The feel, it just, man, it's lighter than almost anything. I mean, I think this one probably weighs about the same as this one, and you can see how much smaller it is. It's flimsy. The fit, the finish, it feels kind of like a sharp edge. I mean, it's not like it's going to cut you, but the seam between the front and the back, yeah, it's just attention to detail. The feel of it, man, it's flimsy. I mean, all calculators go like that to anything. It's going to flex, but man, this one's just like super flexy. I don't know. Whoever designed this, shoot them, bury them, dig them up, reincarnate them, and shoot them again, because, man, they just got everything wrong. And the buttons, they're so floppy. You know, the one's like at an angle, the mode's like this, the delete key, you can see it's kind of up like that. They're so, I don't know if you can hear that in the microphone, but they're so loose they wobble around. Really? Oh, what happened to you, Sharp? And, like I said, this calculator, brand new out of the box, had a corroded battery. Oh, shame, shame, shame. Giving the old Sharps a bad name, man. So I think that pretty much covers most of the basics. Just a quick overview of calculators. Like I say, in the second part of, or the second video, what I want to do is I want to show a trap. So depending how you input stuff into the calculator, you might get different answers out. You type it in one way in this one and this one, you'll get the wrong answer. You type it in this one, you get the right answer. You type it in this one, you get the right answer. That's Texas Instruments, that's a Casio. Those will both give the correct answer. These will give the wrong answer, depending how you type it into the calculator. So I want to show that. Really simple. Not that it so much pertains to electronics, because honestly, what you'd be doing in electronics isn't going to be that hard for a calculator to calculate. But if you do probability or statistics, where you're doing like summations, where the amount of math that a calculator has to do is phenomenal. I mean, it's just how many things it has to do to get to the answer. That's where you'll notice a difference in speed. So this calculator might take like 30 seconds. This one might take a minute and a half. That HP Prime over there, the instant I hit enter, the answer's there. That thing runs, I think, a 400 megahertz processor. These obviously don't. Now, like I say, for electronics, you'll never notice a difference. You're never going to be doing summations of like x equals 1 to 500 or like x equals 1 to 1,000. You're never going to be doing that kind of stuff in electronics, so you'll probably never run into even noticing that, you know, when you hit the equals button, it takes time to get the answer. Most of the stuff you're going to do in electronics, the instant you hit the equals button, even on this one or this one, the answer is going to be there. But with really complicated, you know, if you're in school taking, like I say, probability or statistics, the speed is definitely, there is a huge difference. I want to show the demonstration of programs, how they can make your life easier, and just a general, so you can see the difference between some of the different manufacturers of calculators, how entering in some of the special functions can be a little bit different, how what might be on the outside on this one with just a shift and hit a key. In another calculator, you'll have to go into a menu. So just, you know, show that a little bit. Show how nice this display is. Like I say, impressive for the money. It's just wow. The quality of the display on this, the resolution is just impressive compared to all of the other ones on the bench, except for the you know, really high dollar color calculators. So I guess I'll wrap it up here for part one. I'll get most of these cleaned off the bench. I'm probably going to have like this one and this one, maybe the Texas Instruments, and I don't know, maybe a Canon, to do like some of the speed testing and just show the different styles of input. That there are differences, and some of them are easier to input stuff in than others. Like I say, this one, it's a great calculator. It just is a little bit more clunky to use than these calculators. And I can show that. So let me get that set up, and that'll, I think, end it for this one. So tune in for part two and watch some actual practical use of calculators.